This is a brief description of the TLS protocol. TLS protocol is how your data is secured as you transmit it across the internet. It uses encryption to mask the data. Encryption is where you change one thing into another form so that it's unrecognizable. When you encrypt data, you use mathematics with a special number to change it so that it's unrecognizable. That special number is a key, and there are two types of encryption. One is where the keys are the same. That's called symmetric key encryption. The other is where the keys are different. That's asymmetric. A special form of asymmetric is public-private key encryption, and that's where one key is held in private so that nobody else knows what it is, and the other is published generally. Everybody knows what it is. When you use public-private key encryption, it's public key infrastructure. TLS uses a concept called a digital signature. A digital signature uses public key infrastructure to ensure the source of the data. A digital signature is effected by encrypting an important piece of information with the private key and allowing another party to decrypt it with the generally available public key. Digital signatures that ensure websites are called certificates. So, in order to ensure that a website is authentic, it will send you a certificate, which is a digital signature, which is a piece of data encrypted with a private key known only to that website. You will have the public key and you will decrypt it and know that you are dealing with that website. With public key infrastructure, digital signatures, certificates, there are two assumptions. One is that only the intended party knows the private key. The second is that you have the correct public key. Two very important assumptions that have to be verified. So, one thing that a consumer can do to ensure part of that is verifying that they have the public key. A verifier of a public key is called a certificate authority. So your computer will ask a certificate authority whether this public key is the correct one for the website you intend to communicate with. How would your computer do that? It will send the public key to the certificate authority, and the certificate authority will respond back whether it's accurate or not. The issue is, how do you know whether you're dealing with the correct certificate authority? Because that's on the network also. Well, your computer has all the public keys for all of the certificate authorities. Your computer was shipped most probably by Microsoft with all of the important certificate authorities public keys. So after you've ensured that you're dealing with the website by public key, private key encryption, digital signatures and certificates, and a certificate authority, can you now communicate securely with that website? Well, you can't, because if that website sent you data encrypted with their private key, anybody with the public key could decrypt it. Also, if they did that, it's much slower than symmetric encryption. It's very slow. So what you need to do is share a symmetric key with that website And the way you will do that is encrypting a symmetric key with the public key and send that back to them. Since they have the private key for that public key, they can decrypt it and will know the symmetric encryption key. Then you can both use the same key, which is a lot faster than public key, and nobody else will know those keys, so that data will thereby be secure. That's TLS protocol and how information is securely shared over the internet.